Well, good morning, Math 3 students. This is week 2, lesson 2. Today we are looking at some notes only. There is no Delta Math practice to go along with this. We are doing some work with the unit circle to help prepare for the next practice that we have. So let's take a look at the unit circle. The unit circle has a radius of 1. And so we're still looking kind of in our polar rotational angle situation. So obviously over here, on the positive x-axis, we have 0 degrees. And on this circle, that point then is 1, 0, because it has a radius of 1. Rotating counterclockwise, we've got 90 degrees up there, 180, 270. And so, of course, the points go with 0, 1, negative 1, 0, and 0, negative 1. One of the pieces here is trying to work out, well, what's a great way of remembering some specific angles and the radian angle values that go along with it. So here we've got 0 degrees. Well, that's definitely 0 radians. Hopefully, you know by now that in a circle, we have 2 pi radians. So if we were looking at 360 degrees, one rotation, that is 2 pi. Well, let's talk about some easy ones, like halfway around the circle then is half of 2 pi. That's 1 pi radians. So 180 degrees is 1 pi. So then let's split it up on that top half then. That 1 pi, well, half of the way to pi is pi over 2. Pi over 2. All right, now we got to break it down a little smaller. So here we've got 30-degree chunks. So that's 30 degrees. That's another 30 and another 30. So this 30-degree piece, that is 1/6 of 180. So that's 1 pi over 6. That next 30-degree chunk, that would be 2 pi over 6. Well, that reduces to pi over 3. And then, of course, 3 pi over 6, well, that reduces to pi over 2. So let's keep going. 4 pi over 6, that's 2 pi over 3. 5 pi over 6, well, that doesn't reduce, that's just 5 pi over 6. And then 6 pi over 6, well, that's 1 pi. So let's keep going. 7 pi over 6. The next 30-degree chunk is 8 pi over 6, which reduces. 4 pi over 3. Next chunk, well, I lost count. That would be 9 pi over 6. That's 3 pi over 2. 3 pi over 2. 10 pi over 6, that reduces. 5 pi over 3. And 11 pi over 6. We get back to the last piece, 12 pi over 6, that's 2 pi. So that took care of all of the sixths and how they reduce. You can see some other fractions in there, like 1/3 of pi, 2/3 of pi, 3/3 of pi. That's a whole pi. Keep going. 4/3 of pi, 5/3 of pi, 6/3 of pi. So we'll keep going. So I skipped these because they're not based on 30 degrees. This is halfway between 30 and 60. This is a 45-degree angle. So 45 compared to 180, that is 1/4 of pi. So that is pi over 4. 2 pi over 4, that reduces to pi over 2. 3 pi over 4 is over here. 4 pi over 4 is 1 pi. 5 pi over 4 down here. 6 pi over 4 down here reduces to 3 pi over 2. And 7 pi over 4 over here. So that takes care of all of the radian angle measures. But what about the coordinate pairs on these points? They all have a radius of 1. So what about the actual x and y values? That's where special right triangles come into play. We've been working with them a lot this year. And so on our 30-degree angle, which we now know is pi over 6, well, the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. But on this circle, the radius has to be 1. So we got to get that hypotenuse down to being equal to 1. So let's just divide everything by 2. Divide everything by 2. That means that at the 30-degree location, our x value will be the square root of 3 over 2, and the y height will be 1/2. Something similar happens over here on our 45-degree angle, our special right triangle. We have legs of length 1 and 1, and the hypotenuse is the square root of 2. But again, the radius has to equal 1. So let's divide everything by the square root of 2 to break that hypotenuse down to 1. Well, this is okay, but it's not the common way for us to write that because it's not in rationalized denominator form. So this would be equivalent to the square root of 2 over 2 if we rationalize that. So again, that's our x value and our y value. Same special right triangle as before, but oriented differently because of the 60-degree angle that we're seeing there. So we've got our short leg of 1, our hypotenuse 2, long leg of square root of 3, but same issue, divide that hypotenuse by 2 to get the radius down to 1. So now our x value is 1/2, while the y value is the square root of 3 over 2. So if we start putting these x and y's together on our unit circle, here's what we get. On our 30-degree angle, we get square root of 3 over 2, comma, 1/2. For the 45-degree, we get our x value, square root of 2 over 2 in rationalized denominator form for both the x and the y. And lastly, for our 60-degree angle, here we go. We have our x value of 1/2 and the y value of the square root of 3 over 2. So obviously, between the 30-degree and the 60-degree, the x and the y just get flip-flopped because of that connection from the same right triangle. So the issue here is that's kind of a lot to go through. It's kind of a lot to remember just to put down here. So here is a really quick way of remembering this. Okay. So on these three, because we already know this angle is 90 degrees and the point is 0, 1. And we already know this one is 1, 0. So just on these three, start at the top. Okay. For our x and y, they all have a denominator of 2. Every single one. X and y on every single point. They all have the denominator of 2. So go through, write those down. Next up, starting at the top, start 1, 2, 3, and then go backwards. 1, 2, 3. 1, 2, 3 down, 1, 2, 3 back up. And then lastly, apply a square root to every numerator. The square root of 1 is 1, so we're going to leave that. This is the square root of 3. This is the square root of 2, square root of 2, square root of 3, and the square root of 1 is 1. So that stays put. That's exactly what we wrote down. That's exactly what we got from our special right triangles. So what about the rest of the circle? Well, it's all symmetric. It's all symmetric. So for pi over 3 and 2 pi over 3, the only change is that your x value is now on the negative side of things instead of positive. So negative 1 over 2, square root of 3 over 2 is your height. It's a perfect mirror. Pi over 4, 3 pi over 4, your x value is negative. That's the only change. For 5 pi over 6, same thing. Negative x value. That's the only change. Y heights stay the same. So what about down here? Well, it would be a mirror image of quadrant 2. So you've got a negative x value that matches, and you would also make your y value negative. And lastly, in quadrant 4, you would be mirroring quadrant 1, for example. The x values would stay exactly the same, but your y values would be opposite. So as long as you can build your first quadrant, you can build the entire rest of the unit circle values. So fill those out, finish up your unit circle, and good luck out there. Remember, there's no Delta Math practice today.